Okay, good morning. This is the Gardener community meeting. Today we have three topics. First, Christoph will talk and demo how to extend a local Raspberry Pi cluster with cloud instances. Let's see how this is related to Gardener. And then Rafael has two topics, vertical pod autoscaler for shoots and automatic stale project deletion. So I will now unshare. And then Christoph, it's your turn. Welcome.
Thank you very much for the invitation. Matthias kindly asked me to give a presentation of a blog post I published like 2 weeks ago. It's actually like a hobby project, and I would like to guide you like through this blog post more or less, and like giving you some motivation. Why I want to extend local Raspberry Pi clusters with cloud instances. Just to drop a few words about me and myself, I'm a consultant at Storm Reply. Storm Reply is a AWS specializing consultant company. I'm working there as a kind of Kubernetes expert, specializing in everything Kubernetes and cloud native technologies, and helping there to build Kubernetes-based architecture to be developed there, and also take over parts of operation. When I'm not working, I'm organizing the Hanover Gophers, like the local Golang meetup here in Hanover. Also, like, while it's not COVID time, so hopefully this time will pass soon. And since this year actually, I started a blog together with my dear colleague Max Körbecher, talking about news of the cloud native world. And we try to achieve a weekly newsletter. So far, we proceed quite good with this. And every now and then, we are also publishing blog posts like this, what I'm going to introduce you right now. So, deeping into the topic, like the motivation. I wanted to have a cheap and reproducible and actually also persistent Kubernetes cluster for testing, playing, and some hobby purposes. I have some workloads like CalibreWeb or others that I would like to operate locally. I would like to have access to it every time, and every now and then I also find some fancy new technology which requires a Kubernetes cluster. But the problem is that like my local Raspberry Pi cluster, is kind of fancy, but also quite limited with 1 GB of RAM and only 2 instances. You can imagine that not much fits into this. Also, the second limitation is that usually or most of the images are not built for ARM, but only AMD 64. Which makes the majority of workloads actually hard to operate on Raspberry Pi. Then, as you probably know, quite a few managed services for Kubernetes are already out there. But to be honest, they are still quite expensive, at least if you want to keep and maintain a persistent cluster. This is actually out for me for my local budget. And also, I was digging and experimenting with Kind, which is extremely awesome technology, but first, it's also not persistent. It's shutting down as soon as I shut down my notebook. And also, I have a 16 gig MacBook Air, and Docker is still eating quite a few resources there. So to give you some background, a few months ago, I found an amazing technology called Tailscale. Tailscale is based on WireGuard, and it's allowing P2P connections between devices. And Tailscale is basically maintaining the whole authentication part. Like it's possible to authenticate via single sign-on, and also the whole secret rotation, so the certificate rotation. So you don't have to mess with anything complicated, which WireGuard usually brings with it. And yeah, it basically allows you to create a P2P connection between one or multiple devices. And I did some experiments with it. And of course, I was trying to build my local K3S cluster based on Tailscale. And I figured out that it's working quite nice. I was also like almost quite surprised at how nice it worked. And I was then extending my local network with AWS EC2 instances and also with DigitalOcean instances, and found out, okay, it's actually quite easy to have a heterogeneous Kubernetes cluster. And the only drawback there is that you kind of need to provision those instances. So they are like either you do it manually or you can configure or script it with some fancy Terraform. But in the end, you still need to have a machine which is executing this Terraform scripts just to provision those machines. And then I was remembering back at one of the KubeCons where I was talking to people from Lutz, or nowadays called Kubernetes. They presented their Kubernetes solution, and I was kind of reminding this machine controller, which is actually abstracting Kubernetes, or which is actually abstracting cloud instances in custom resources within Kubernetes. And it was possible to define nodes of your cloud provider with Kubernetes manifests. And so I was directly digging into this and found out some drawbacks here, because the first thing is, as I mentioned, I'm not running a fully fledged Kubernetes. I'm actually running K3S. So the first thing is I somehow need to make sure that this machine controller is running on my Raspberry Pi, so on ARM. And the second thing is that this machine controller is able to spawn instances which are able to join a K3S cluster and not necessarily a Kubernetes cluster. So I was digging into this a little bit and found out that the machine controller, like the architecture how it currently is packaging the user data right into the binary. So this means the user data is already pre-baked, and the user data actually contains the whole logic, like what needs to be done in order to join a cluster. And I already know that I want to alter the user data in a way that I can join this K3S cluster. Also, the second limitation there is, even though I'm somehow able to adjust this user data, it will probably still try to deploy AMD64 binaries. So the only way around, at least what I found out or anticipated, was building an own AMI image. This is was actually for me a little bit too much overhead, also like for later to maintain. With some more research, I then found out about the machine controller manager from the Gardner guys. So thanks again for bringing this up. And it has actually, like, at least for my purpose, a smarter way to handle this whole thing. So it does not have any knowledge about the node or the operating system. And also, it doesn't have a strong opinion like how this node should join this cluster. So it is directly possible to define the machines with YAML, and also it's directly possible to store some user data in a secret, which then is used to provision this instances. So actually, like, the preconditions are met. I was trying this out, and the only problem then remained was that, Machine Controller Manager was actually built with AMD64 in mind, and also not necessarily with K3S in mind. So it was kind of an experiment, what needs to be done to make it running on the K3S Raspberry Pi cluster. So this is the anticipated, like, overview, kind of. I have my my Raspberry Pi 1, which is my master machine. The Machine Controller Manager is running there, and ideally, this is creating EC2 instances on demand, or like when as soon as I increase some replicas. And this is where I would like to demo something. So I will not show you like what needs to be configured and everything, because like the basic walkthrough, what needs to be done in order to achieve this, also like a Git repository where like example manifests are available. I provided this in my blog post, so I would just like present you the solution kind of. I currently have my cluster. I already have an AWS instance spawned here. This is currently a TC micro instance with a Ubuntu image. Yeah, I did some minor things like adjusting security groups and also giving this some proper IAM roles, because I also want to make sure that my machines that are spawned by my cluster are not able to do too much within my AWS account. And of course, I'm also providing some AWS secrets, which refer back to a role with necessary permissions for the machine controller manager. As you might know, this machine controller manager is basically the operator which is running in the cluster, which is continuously checking for a machine deployment. This machine deployment is currently set to 1 instance, and just for the demonstration, I will scale up the number of machine replicas to, let's say, 3 instances. And as expected, we already see that that the machine controller manager noticed this and is trying to start those instances. In the meantime, we can go into my AWS account and check whether we can already see them. Hopefully I'm still logged in, otherwise I will need some time. Yeah. So let's see whether who's faster, me logging in or
we still see the terminal.
Yeah, you still that's actually this anticipated because I don't want you to see my login interface here. What the heck? Okay, I think we for now just need to trust that those instances are spawning, because I'm somehow not able to log into my account, but nevertheless. In the meantime, I will show you some more about Tailscale, which what you're currently seeing here is the administration interface, and I already have quite a few nodes as part of this network. So you see my Raspberry Pis with the masters and workers. And you also see this is my local machine, my MacBook, and also Tailscale provides some more clients for iOS and nowadays also Android. So I can install Tailscale on my iPad and in my iPhone, and I can then directly access, as soon as I have a terminal, my machines, which is actually quite handy if you're like on the go or something like this. And what we're also seeing right here is that that we have some more instances here. So this means that the AWS instances already spawned, and that yeah, Tailscale is already provisioned and that it's already joined the network. And what we see now here is in the cluster that we have, yeah, some additional new instances, which is pretty neat. So everything achieved what I wanted. I can now provision them. There's one thing to mention. Due to the fact that these are TC micro instances, they have now another processor architecture, which means I spawned AMD64 machines, which means in fact that I have to work with node selectors as soon as I want to provision some software. This is just something which needs to be kind of kept in mind. Coming back to the presentation, I want to talk about some challenges, because obviously you saw it's working nice, but in fact it took me quite some more time than anticipated. One of my first challenge was finding the right permissions. Yeah, the kind of guys from Gartner were so kind to help me out within their Slack channel on the CNCF Slack. Then the second problem I was facing, and actually took at least 2 days to figure out, up until I talked to Hardik. He was very patient to help me out there, so thanks again. I had the issue that the instances were joining the cluster, but the machine controller was not accepting them as ready, and they always had the pending state up until they were removed from the cluster, because the machine controller manager was assuming, okay, the nodes are not ready, they are not in the ready state, I will just remove them and try to restart them. And then Hardik explained me basically there are 2 requirements that needs to be met. So the node name must actually match the status name of the machine controller manager. And here's the issue, that the machine controller manager, or at least the provider, the AWS provider of the machine controller manager, is starting the AWS instances. Those are spawned with this kind of name. So in fact, I had to just take over this naming scheme for also the actual node name, which is used by the kubelet to join the cluster. Luckily, it's relatively easy to retrieve this this name by using the metadata of AWS. And the second condition was actually that the provider IDs must match. So AWS instances are expected to be spawned from the controller manager with this kind of scheme, like AWS : / and the region, and also the instance ID. And K3S by default, without any kind of cloud controller, is spawning with this K3S and then the host name pattern. But luckily, this kubelet argument can also be overwritten. And again, I can retrieve the metadata information also from the AWS services. Actually, to be honest, it would have probably cost me some more time to figure this out, at least without reading code, due to the fact that this was K3S. I was already doubting that this is even like possible to run, but yeah, this was making it obvious. After the joins, after the nodes joined successfully, I had another problem, which was basically a connection issue. I had the issue that pods on the same node were able to connect to each other, but they were not able to connect across nodes. So the problem was, I pretty soon figured out that the problem was that the overlay network is not using the Tailscale interface on the machine, but it's using the default interface. And I pretty soon found out that there's even a flag for like the Flannel overlay network, which is used by default from K3S, to use the Tailscale 0 interface. But for some reason, it still didn't work, and it took some more hours until I figured out that my local version on the Raspberry Pis of Tailscale were quite old, and I was provisioning the AWS instances with a rather new version of Tailscale. And yeah, there was some buggy there were some bugs in the older version which prevented actually that they are properly communicating. Updating them, and everything worked like a charm. So with setup, I'm actually quite surprised. It's running since 2 weeks very smoothly, and I'm using it regularly, but it still comes with some limitations. Actually, some limitations I anyways have with this Raspberry Pi setup. So the first one is I have still no cloud controller, so I cannot provision any load balancers to my AWS instances. Also, I cannot use the Kubernetes native way to create persistent volumes. So in order to create EBS volumes underneath, this is it's a drawback, but it's actually also not a problem. In fact, I intend to also extend this cluster maybe to also some DigitalOcean instances. So that's currently the fact, and some limitation I need to be aware of. And also, like, the maximum amount of nodes still remains. So according to the documentation of K3S, a Raspberry Pi 3B master node is probably able to handle about 10 worker nodes. I just need to keep this in mind to not make the control plane too busy. Like the next steps, now what? In the meantime, the out of tree providers are there, which means I do not anymore need to adjust the machine controller manager code base itself in order to bring up some new providers, because my plan is to create an out of tree provider for DigitalOcean, which is unfortunately not yet there, but I read some documentation. It looks to be pretty straightforward. And the second point or problem, this is still a custom ARM build, which I just hacked away. I would like to bring up a GitHub issue, like talking about multi-architecture build for MCM, which also provides the capability of running the machine controller manager on ARM setups in general. I assume that ARM is becoming more and more important, and AWS just recently announced that there are also ARM instances which you can like directly create in the cloud. They are even to some extent cheaper. And so I think the use case is definitely there, even though that when you don't want to create Raspberry Pi clusters. Yeah. And as a reminder, if you want to like dig into the details and like how I set up the user data and this kind of stuff, you can always read the blog post. I will share the slides afterwards. And with this, I thank you for the invitation again. And are there any questions?
So yeah, thank you very much. This is Vasu. Thank you, Christopher. I have a question with respect to the daemon set. For example, you use Flannel for the overlay network. Didn't you have to adjust for the multi-architectural setup? I mean, you have Flannel on ARM and then Flannel on. These are different containers you have to pull. You mentioned that, but how did you approach that?
That's a good question, but luckily, this is already taken over by K3S. So K3S is actually wrapping all the Kubernetes components into one binary, which includes the kubelet, the proxy, and also like the overlay network. But if you want to use another kind of overlay network, you can of course install it, and then it's actually a daemon set. Otherwise, the Flannel setup is part of the K3S binary.
Okay, so you were actually spinning up K3S on the x86 instances as well, and exactly. They have a multi-build. Okay.
Exactly. So the whole cluster is basically built upon K3S. So I'm not merging Kubernetes like vanilla Kubernetes with K3S.
And this is great. It's a super use case for hobbyists. Yes. Thanks a lot.
Exactly. yeah, and the comment, it's definitely a hobby thing. So I don't think that you should run this in production. I also have some or a smaller issue regarding secrets, because currently I'm writing like the secrets to join the Tailscale cluster and also the secret to join the K3S cluster, more or less raw as part of the user data. If I would have something like a secret manager, of course, this would be more handy, but that's how it is currently, and it's working for me.
Okay. What kind of application actually do you run on the cloud side? Is there some home automation or something like that?
So to be honest, right at the moment, it's the Prometheus operator. That was the main point, because it's quite resource heavy. But apart from this, I'm planning to run something like Nextcloud or something like this to also leverage the S3 there. And also, I mean, the fact that the controller manager is not there doesn't prevent me from actually attaching still a load balancer or an EBS volume to one of those nodes. So this is also maybe something I would like to do.
Nice.
Yep. Then thank you very much for having me.
Thanks, Christoph. Amazing experiment. Thanks for the demonstration. Any other questions to this talk?
This is Amshu. Can you hear me?
Yes.
Okay, Christoph, very nice experiment and demo. It's very. Just wanted to ask one question regarding changes that you had to do for K3S as against what the machine control manager right now does for Kubernetes. I understand that you had to change the code in MCM because out of tree may not have been there at the time, but did you have to make any changes apart from the driver part to talk to the cloud or to the actual flow of MCM anywhere? Just because now it is K3S?
Not at all. I was also quite surprised. So I didn't have to adjust anything on the MCM. So I just had to make sure that, as I said, that that K3S is spawning actually the nodes in a way, or like the K3S agent, and is spawning the nodes in a way as machine controller manager is expecting them to join.
Okay.
If you want, I can also show you this as part of the user data. So this is basically the example for the whole user data. So I left out the tokens and everything. And this down here is in the end the logic which is responsible for joining the node. And actually I directly downloading K3S and just giving it some additional flags, like which is the node name. And the most important thing is also the provider ID. As I said, also the Flannel interface is important because otherwise Flannel will use the default network interface. Also important is that like the external IP, which is used by K3S in the end, is actually the IP which is provided by Tailscale, because otherwise the master would not be able to reach the node, the client. But to answer your question, I did not have to adjust anything of the machine controller manager, except for providing a ARM build and ARM image.
This is so cool.
Everybody's amazed.
Yes.
Opens up new opportunities for Gartner, right?
Yeah. So my question is, it's ARM 64 or just ARM 32 bits?
This is currently just ARM, but yeah, if I would have some Raspberry Pi 4s, I think the latest version is also able to run ARM 64, at least with the new Raspbian operating system. I guess I'm not 100% sure, but yeah, in theory, this would also be possible, I guess.
Andreas here. One question regarding the pre-provisioning of the Tailscale keys. It was actually one of the learnings I had from your blog post, because I didn't know this was possible. what's your experience with that? Because I didn't try it out yet. Typically, I just manually design and.
Yeah. So the provisioning of or the fact that you actually can automatically or that you can join a cluster with a pre-configured key is actually currently a beta feature. I think it's still a beta feature, and so it's drawn somewhere in the documentations, and you can provision this key via the administration interface. What I kind of dislike about this is that it's not possible to somehow rotate this key yet, or like that you cannot, that there's no API to create this kind of key. In my opinion, this is kind of a security concern because I would like to have some iteration there. Yeah, but apart from this, going into the UI, providing the, or yeah, generating the key and then just handing this over to the user data.
Cool, thank you.
There's maybe another thing to mention regarding Tailscale, which is also interesting because once I'm deprovisioning the machines, the Tailscale still assumes that those machines are part of the network, so they will still be part of the administration list, but will be reported as like offline. There's currently at the moment no disconnect feature or something like this, because I would like to have a feature that as soon as my instance is terminating, that I'm actually disconnecting from the Tailscale network, because I'm pretty sure that this specific instance will never come up again. In theory, you could also run this Tailscale client as part of a container. So this is maybe also something I would like to experiment with. And yeah, that's some drawback currently. So I now have to manually clean this up in a way. Maybe also in addition to this, I was extending this setup a little bit with Reflux. And yeah, Reflux is actually usually managing the amount of nodes. So whatever I have in my repository configured, Reflux is trying to apply this to my cluster. Which actually makes sure that even though I turn off my Raspberry Pis or need to reprovision them in a way, I can still be sure that like the right amount of external nodes is still available, or will be provisioned, as well as the same software I'm running on the cluster. So I'm already over time. So again,
thanks a lot, Christoph. This was really a nice demo. Thanks for the experiment. Keep on this good work.
Thank you.
If there are no more questions, then we can go to the next two topics by Rafael.
Yeah, hello everybody.
Hi.
I have two small topics about two improvements that I made in the past weeks. Let me share my screen. Right, so the first one is about the vertical pod auto-scaling feature for shoot clusters. It was introduced with this pull request here. Maybe a quick look at the Gardner architecture to explain why we did it. So here in the middle, we see the seed cluster and a typical, the control plane of a shoot that runs on the seed cluster. And since quite some time, we already provisioned this VPA also in the seed cluster, which means that we can vertically scale up or down our control plane pods that are running here. So this we have in place since many releases, and extended it also with a HVPA, for example. But yeah, until this pull request, it was limited to the workload running in the seeds. So my pull request now also allows to have the VPA for the shoot cluster, so for the components here in the right box. So far we were not able to vertically scale up or down, for example, core DNS or our VPN, or also the others, of course, which, yeah, sometimes depending on the end user's workload led to issues where, for example, the core DNS ran out of memory or got CPU throttled or so. And this is, of course, something that we want to avoid. Yeah, and this is yeah, why we did this VPA support now also for the shoots. Then I will quickly demo it. So I'm having here a garden cluster, and in my dev project I have one AWS shoot. The connection broken. Do you still hear me?
Yes, we hear you.
Oh, okay.
But it seems AWS doesn't hear you.
It should be my local system.
Oh, okay.
Did you switch on the VPN after running local garden up?
Maybe. Let me quickly reconnect. Sorry. Okay. Yeah. So this is my AWS cluster 1.18, and I will now edit the specification and enable the vertical pod autoscaler. So it's currently disabled by default for the reason that we already have many existing clusters and end users might have already deployed the VPA on their own. So we cannot simply enable it by default, because then we would have 2 VPA deployments and this would probably cause issues. So for now, you would have here in this section, similar like you configure the cluster autoscaler, you can also now configure the vertical pod autoscaler. And you would have to set the enabled value to true. And then some other configuration options will be defaulted here that you can also modify later to fit exactly to your workload in the shoot cluster. So these are currently just the default values. And now it will take some time. The reconciliation will start. And it will actually provision the VPA components into the seed cluster in the shoot namespace. Yeah, so in a few minutes, we will see 3 additional deployments here, the admission controller of the VPA, the recommender, and the updater. And these components will, similar like all the other components that we have here running as part of the control plane, cluster internally talk to the Kube API server of the shoot, but still manage the workload here on the right side in the shoot cluster. This is an empty cluster, and what will also happen automatically is that we will, for most of these system components that are here managed by Gardener, configure a VPA resource so that they will be put under autoscaling. So it means that not only the system components can then be vertically autoscaled, but also the end user can create additional VPA resources for his personal workload. Till we see it live. I point you to the documentation. So in the Gardner repository under the usage folder, there's some documentation which also explains the various configuration options. Is it already? The Cube API server just got restarted. This is because we have to also deploy a network policy into this shoot namespace here in order to allow the Cube API server to communicate with the VPA admission webhook. And yeah, in order to make the network policy effective, we have to restart the pod. You have some questions in the meantime? I think it should be ready in the next minute or so.
So this is the standard upstream VPA. We didn't need to modify anything.
Yeah, the problem was that the VPA is currently assuming that it runs in the cluster that it serves. So, but in our scenario, it runs in a different cluster, right? It runs in the seed, but serves the shoot cluster. And usually you can simply provide a pre-configured kube config to these components, and then they will fall back to this kube config and connect to whatever cluster, wherever this runs. But in the VPA scenario, this is not implemented at all. So they only can work with service accounts that are mounted into the pod. So we had to do a little trick here in order to point them to the right cluster. So we might want to contribute this feature that you can configure them with the kube config that we point to the shoot, and then we can go the standard way like we do it for all the other components.
Okay, and we'll contribute that pull request that's in the plan.
Yeah, probably. It will also make our setup a little bit easier then. Mm-hmm. As you can see, these three components have been deployed. And in the shoot, we should see the vertical pod autoscaler custom resources that have been created. And for the system namespace, we should kubectl issue. We should also see the VPA objects for our system components. Most likely, some of them were already restarted in order to get proper resource limits and requests assigned. Right, that's it for this feature.
Nice.
The disadvantage is, unfortunately, that this custom resource definition here is now managed by Gardner. So this means if the user creates VPA objects for his own workload and later on disables the VPA again, then also this custom resource will be deleted. And with it, all his custom configuration. Right. Then I jump to my second topic, which is about the auto deletion of stale project resources. So the rationale behind this improvement is that Gardner is generally designed to be used by a lot of people eventually. And over time, those users will most likely create a lot of project resources in the system. And some of them might use the project very actively. Others will just create it and then forget about it and don't use it anymore. But still, these resources remain in the system because most people don't want to forget to actively delete the project if they don't need it anymore. So this improvement is implementing some auto deletion for such unused projects after a certain grace period that can be configured. And projects are considered unused if they don't have any shoot resources, plans, or backup entries, or if they also don't have any secret resources that are used by shoots and other namespaces, which is generally possible by having a secret binding that points to the secret. So if all these conditions are met, then the project is considered as stale. This means that in the first step, it will be marked as stale with a timestamp since when this situation has been detected. And after some further grace period, if the user is still not using the project anymore, the controller will compute a timestamp at which the project will be auto-deleted. The default values for these things are, I think, 90 days plus additional 2 weeks as a grace period. So if the end user doesn't use his project for, let's say, 3.5 months, it will be garbage collected, so to say. Then I will also show this in a small demo. So I have here the dev project, where also the shoot that I just used resides. And in the dev1 project, there is no resource at all. This is currently unused. And when we now look at the configuration of the controller manager, you can see there are 3 values. The first value here, minimum lifecycle days, states that only projects that are older than 30 days are considered for these stale computations. So this is in order to not directly mark projects as stale when they get newly created, because obviously they are not used when they are just created, and allow end users to get familiar with the system, get some time, and only after the project is unused or created for 30 days, these computations will start. So this project here, dev1, is 1 hour old. And you see in the status, there is no indication that this project is stale in any way. So this is because of this configuration. When I now set it to 0, it means there is no such grace period. And also new projects will be immediately considered. So you now see in the status, there is a stale since timestamp, which is just now, which can also later maybe be used in the Gardener dashboard to show to the user that this project is currently not used and maybe should be either deleted by the user if he doesn't need it anymore, or eventually be used again. So now the second configuration value, the stale grace period that I also just mentioned, tells that only if this situation here lasts for 14 days, only then this auto deletion timestamp will be computed. So yeah, of course we would have to wait 14 days if we would keep it like this. So I change it again, restart the project controller. And now you see also this auto deletion timestamp has been added to the status, which is today plus the configured 90 days, as it was stated here. Okay, now the user has time to maybe use it again. He could simply create a new shoot resource, for example, in this namespace, and then these timestamps would have been removed again. Otherwise, at this point in time, the project controller will go ahead and terminate it. So the good thing is that you can also later change these values here as an operator. So if you want to allow the users more time, you can, let's say, set this to 2 days again. And then 2 days from this stale since timestamp are right now not passed. So the auto deletion timestamp is removed again. And it will be only added on Sunday. Okay, and when I set all the values to 0, the project controller will immediately terminate the project when it's not used anymore. This just happened. So you see the auto deletion timestamp is now, and the project is in the phase terminating. And when I try it again, it is already gone. Of course, this is just for the demo purpose, but the redo values are the defaults here. So people should have enough time to use their project or terminate it themselves. Also, there is, for this feature here in the concept section, in the controller manager documentation, the explanation what the controller is doing exactly and what are the concrete criteria, and the various configuration options and their rationale. Do you have questions for this feature?
Thanks, Rafael. Seems not to be the case. Or is there any question? Do we have any other topics to discuss today? Okay, then see you next time. Bye-bye.
Bye. Thank you. Bye.